Hello everyone, I am Anushka Srivastav. Welcome back to my channel. So this is my 7th lecture in my data science playlist. So let's see what are the topics that we are going to discuss today. Today we will discuss neural networks. So what do we understand by the term neural network? Neural networks are computational model inspired by the human brain, consisting of layers of interconnected nodes. Each neuron processes input data and passes the output to the next layer. The architecture of neural networks allow them to learn from data, making them suitable for various data science applications. Neural network plays a significant role in data science, serving as a powerful tool for analyzing and interpreting complex datasets. They are particularly effective in tasks that involve large data and requires the identification of intricate patterns. Let's discuss some key components of neural network. So the key components of neural networks are as follows. Number one, neurons. The basic unit that receives input, apply a transformation and produces an output is known as neuron. Number two, layers. There are majorly three types of layer, that is input layer, hidden layer and output layer. The first layer that receives the raw data is known as input layer. The intermediate layer where the actual processing occurs is known as the hidden layer. Also, the number of hidden layers and neurons can vary based on the complexity of the problem. The final layer that produces the output, such as class labels or continuous values, is known as the output layer. A third concept or component is activations functions. Functions applied to the output of each neuron to introduce non-linearity, enabling the network to learn complex pattern is known as activation functions. Number 4. Weight and basis. Parameter that the network learn during training. Weight determine the strength of the connection between the neurons while base allow the model to fit the data better. Let's discuss some type of neural networks. The major type of neural networks are as follows. Number 1. Feed-forward neural network. It is the simplest type of neural network where the connections do not form cycles. They are suitable for tasks like regression and classifications. Number 2. Convolutional neural network. Designed for processing grid-like data such as images. They uses convolution layer to detect patterns and features. Number 3. Recurrent neural network. Incorporate loops to maintain informations over time, making them ideal for sequential data like time series or natural languages. Number 4. Long short-term memory networks. A type of RNN that can learn long-term dependencies useful for tasks like language modeling. So moving further, let us discuss the applications of neural networks in data science. Neural networks are applied in various domains with data science, including number 1, image recognition. Convolution neural networks are widely used for tasks like image classifications, object detections, and facial recognitions. Number 2, natural language processing. Recurrent neural networks and transformers are employed for tasks such as sentiment analysis, language translation, and text generation. Number 3, time series forecasting. Neural networks can model temporal dependencies in data, making them suitable for predicting stock prices, weather patterns, and sales forecast. Number 4. Anomaly detection. Neural networks can identify unusual pattern in data, which is useful in fraud detection, network security, and quality control. Number 5. Recommendation system. Neural networks can analyze users' behavior and preference to provide personalized recommendations in e-commerce and streaming services. Now let's understand how neural networks work. Number 1. Forward propagation. Data flows from input layer through hidden layer to the output layer. Each neuron applies a mathematical operation to its input, often using an activations function to introduce nonlinearity. Number 2. Weights and bases. Connection between neurons have weights that determine the strength of the signal. Bases are added to the weight some to adjust the output. Number 3. Learning process. Neural network learn by adjusting weights and based on the error of their prediction compared to the actual outcome. This is typically done using backward propagation, a method of updating weights by calculating the gradients of the loss function which measures prediction error. Number 4. Iteration and training. The forward propagation and backward propagation process are repeated for many iterations over the training dataset. During each iteration, the network learns to adjust its weight and base to minimize the loss of function. Number 5. Evaluation and testing. After training, the neural network is evaluated on a separate test dataset to assess its performance. Metrics such as accuracy, precision, recall, and F1 score can commonly used for classification tasks while MSE and R squared are used for regression tasks. Number 6. Deployment. Once the neural network is trained and evaluated, it can be deployed for making predictions on new, unseen data. The trained model can be integrated into applications, systems, or service to provide real-time prediction or analysis. So here we are ending our lecture. Hope all your concepts are clear. See you in the next video. Thank you.